Hello, and welcome to a brief 8-slide overview of pharmacogenomics, otherwise known as PGX. I'm your tour guide, Julie Gilbert, your friendly PGX certified pharmacist. Relax and focus as we start the tour in 1950. Well, before we journey to 1950, let's make sure everyone understands the concept of pharmacogenomics. Each of us is made from chromosomes that we inherit from our parents. Obviously, we all have differing lineage, so it only stands to reason that we vary in genetic makeup. These variances play a role in how our bodies process medications. Overly simplified, pharmacogenomics is the study of medications and you. Now to the 1950s. Imagine you're a soldier on the battlefield, fighting malaria even more so than the known enemy. The military sees fit to provide everyone with an anti-malarial agent. You feel great, but your buddy develops anemia from the exact same medication you took. That, my followers, is an example of how different bodies metabolize the same drug differently. From 1906, when it was first theorized that people process drugs differently through World War II, and the anti-malarial drug incident, lots of work was done to understand the process of metabolism. The Human Genome Project started in the late 90s and was completed in the early 2000s. 2005 showcased the first FDA-approved PGX test. It interrogated 2 alleles. Today, we're at 62 genes and hundreds of variants. In 2009, collaborations began with research institutes sharing data, leading to today's authorities on PGX information becoming established. That's CPIC and PharmGKB. 2012 to 2019 was the time of preemptive testing protocols being developed at leading-edge medical facilities. Then third-party payers started seeing the economic value in PGX testing, and coverage began to expand. Once insurers started paying, more and more healthcare professionals adopted this new technology. In 2020, the FDA joined a coalition to promote PGX as the standard of care in clinical practice. Why? Well, as you can see from this next slide, adverse drug reactions are a leading cause of death in the U.S. and most are preventable. The cost savings are enormous, let alone the saving of lives. So let's talk about what really, though, does a PGX test do? On your left is the way dosing has always been done. Clinical trials used to include healthy white males only, no females, and very few people of color. Yet we know DNA varies across ethnicities and sexes. So what PGX testing does is take us from the old days of a one-dose-fits-all philosophy to an individualized expected response based on a person's DNA profile. One person may do fine on the regular prescribed dose, but another may need only half the dose, while another needs double the dose, and yet another can't tolerate the drug at all, and an alternate medication should be used. While traditional pharmacy software applications alert pharmacists to drug or drug to disease interactions, that still leaves about 1/3 of the interactions unknown without a PGX test. Drug to gene interactions lead to about 33% of the adverse drug events patients experience. The only way to warn of a drug to gene interaction is to have a pharmacogenomic test done and on file with all of your doctors. Yes, the test need only be done once. The results may be shared with providers participating in your care. Along with improved clinical outcomes, PGX testing is associated with economic outcomes. When a patient has a PGX test on file, there is a reduction in ER visits, a reduction in hospital admissions, a decrease in death, and a savings of roughly $4,300 per patient in 60 days. So why wouldn't you want this 30-second swab done? If you have any questions at all, whether you're a patient or a provider, please contact us. We are here to educate, not intimidate with regards to genetics. You can reach us through our toll-free number, which accepts text or voice, or through our website, pgxsolutionsusa.com. Thank you for your time today. Stay well.